so we've just got to do a little bit of information regarding anticipation. Anticipating where the object is. And before we do that, I just want to cover an idea about properties you can tell about an object without seeing them. Because if you think about it, oftentimes when we're anticipating something, I'm not necessarily looking at the ball anymore. All right? So I know that as coaches, you often say, you know, you have to watch the ball all the way to your hand, or you have to watch the ball all the way to the racket, but actually that isn't what happens. All right? When you look at experienced individuals, what happens is they watch the ball long enough to judge where the ball is going, and then they look back to the environment to see what's happening in the environment so that they can play a more educated shot with that ball. Right? So I don't have to look at my hand to know that the whiteboard is hard, smooth. Does that make sense? That is called haptic perception. And it's properties about something, about an object that I can tell without looking at it. So what can I tell about an object without looking at it? Shape. What about, think about the balls that we have on the playground. Surface, all right, so texture. Right, because I can tell if I'm holding one of the knobbly balls or a smooth ball. Okay. Great. Sorry?
How hard it is.
How hard it is. Two more. Size. How do I know if I've got an ice cube in my hand? Temperature. Right? So these are all properties of objects that my brain is able to perceive based upon feedback from sensory receptors other than vision. Right? And we use these ideas a lot in sport without realizing that we're using them. Depending which age group you're looking at, you'll remember that our young children haven't learned these concepts yet. So a lot of what you see children on the playground doing is some of them are still putting things in their mouth, some of the young ones. They might like squeeze it or poke it with their finger or rub it on them, right? Because all those different kinds of actions give the brain information that help them learn properties of objects. So one of the reasons we like the knobbly ball is that it gives the brain some more information about timing. When do I, if I'm trying to catch the ball, the feeling of that ball gives the brain a little bit more information to learn timing for the catch. And we use haptic perception often to decide what the grip configuration is going to be, particularly when we look at babies. So if I'm picking this up, all right, I can do it visually and decide how I need to make my hand, or I can, if it's dark, I can feel the object and decide what I have to do with my hand in order to pick the object up. I don't have to see the object because of this haptic information. Right? And what you see with children when they're doing that reaching, grasping, is they look very carefully, and then they hit it, and then they feel it, and then they change their hand configuration. Right? So it's another reason why catching is hugely more difficult than throwing, because they don't have a lot of that information yet, and the visual information on its own isn't enough for them to know what shape to make their hand in order to catch the ball. So, anticipation then. If I'm going to hit something, catch something, kick something, I have to put my body part in the right place to make contact with the ball. Okay? So I can't wait for the ball. Okay? People who aren't very good at tennis wait a long time before they move towards the ball, because they can't anticipate where the ball is going to go. Right? One of the things, those of you that play ball games, one of the things you're really good at is anticipating where the ball is going to be. So you move very early to that place. Right? That's one of the characteristics of someone who's very skilled at something, is that they know exactly what's happening next, and they can be there ready for it. Right? If you watch a beginner, they're waiting and watching, and by the time they move, it's too late. It's already gone. So anticipating has a lot of maths involved. This interception idea involves a lot of calculation in your brain about the arc of the ball, maybe if it's the ball, or the direction the person is moving in, what angle are they at, if I'm going to intercept a person and try to tackle them, where are they going to be, where do I run to? Because if I run where they are now, they're not going to be there by the time I get there. Okay. Clicker! So if we're measuring this idea of interception, then the results that we find are often related to particularly the speed and the size. So when we start with the kids, we start with something that's quite slow. Balloons, you can start with balloons. I don't use balloons on the playground in New Mexico because, oh, we have goat heads. And so balloons are not very successful on a playground in New Mexico, right? But I do have those big, soft balls that fly quite slowly, right? So those replace balloons for me. Okay? So we have to try to set up a situation where their brain is able to calculate where the ball is going to be. Trajectory is another important one because it takes our children on the playground don't have enough experience on the whole. I mean, someone like Kingston, whose dad is a coach, might be different. We've had some kids in the past who do a lot of practice, but generally their visual system and their brain can't track an arc at that age. It takes to around 7 or 8. So when you're tossing a ball towards them, you've got to try to keep that ball as flat as possible. If you toss it up in the air, chances are they'll miss it because they can't track an arc. They can track something that's flat, but arcs cause more problem. So what we see when we look at the research is that they get quite good at the grasping bit, but the anticipation bit is not as good, and we have to put the two together, right? So So they'll shut their hand too early and then the ball will bounce off their hand. All right, so perception action just gives me, we link perceptions and actions, and we'll talk more about these in another chapter. It's very difficult to divide my perception of what's happening with the action that I create in order to deal with that perception. So we'll come back to this idea about optical arrays, the visual pattern on the retina. So the brain, the retina has different cells in it that pick up different information. If you're in a car and you're driving along the road, right, and the car in front of you is getting bigger, what does that mean to you? It's getting closer. So what's happening? You need to brake, right? Because does a car grow? No, right? So you know, because you're an adult, your brain recognizes that a car getting bigger on your retina doesn't mean the car is growing. It means you better press the brake really quickly, otherwise you're going to have a problem. Okay? So when we look at the pattern of expansion or constriction on the retina, that gives your brain quite a lot of information when it's looking at this anticipation, this interception idea. The children will track left to right before they'll track front and back. So when you play with a baby, it's better to roll the ball from side to side than it is to roll the ball to the baby, right? Because it can do this earlier. We're going to come back and do this at another chapter. When we look at the other end of the time scale and we look at catching with older adults, then most of what the research says right now, and there's not a lot of research on older adults, it's an ongoing problem. When we look at movement development, we don't really know very much about what's happening at the other end of the lifespan. But a lot of what we see when we're looking at interception type skills is more to do with a structural constraint that stops them getting where they want to be as quickly as they want to be. So given the experience with the skill, right, given that they're not a beginner at tennis, if they've played tennis, then what we see happen, or they play rounders or basketball or whatever, right? Given that they have that experience, so they kind of know where they're meant to be, the problem becomes, I can't move, I've hip flexibility or leg strength, or I've got arthritis in my knee. So now we see lower scores when we score these types of skills, but it's more to do with the fact that I can't get there in time, not I don't know where I'm supposed to be. Does that make sense? And I still, one of my problems with this body of research, honestly, is that a lot of the assessments they do for coincidence timing are done in a lab. So you'll sit and you'll have a toy, a piece of equipment, and a light will flash, and you've got to hit the light, and then you've got to, based on where that light was, you've got to anticipate where the next light is going to be on the board or on the screen, right? Well, that's great, but that's not what we do when we're out on a tennis court or on a soccer field, or, right? It's not, you don't see a lot of real world type activities when you look at the coincidence timing and the anticipation literature. And that always bugs me, because I suspect that if we did it out on the playground, we'd see something else, maybe. Right? The good thing about the literature, though, particularly the little bit that we have on catching, but again, catching's an anticipation interception task, so we could generalize that to tennis or soccer or basketball, right? Is that we do see that older adults can still improve. So it's not like if I want to start doing it, I'm always going to be awful at it, right? If I'm able to move well enough, I can improve catching, I can improve striking based on practice, even at 60 and 70 years old. I might not ever be really great at it, like if I was 30 years old, but I'm going to be better than I am day one, which is nice, because generally as we get older we tend to think everything's going downhill. So if I'm awful at the first time I try golf or tennis, then I'm always going to be awful, so why bother keeping it up? But that's not true, right? You can get better. The brain is still able to learn. Okay. If I'm improving with practice, my brain is able to learn how to change the motor pattern to be more efficient. Right? So technically that's important, because that means my brain is still able to do that. Right? We don't just give up learning when we're 70 years old. Driving and piloting, both are manipulation skills. So one of the concerns, if you look at the literature on what happens with manipulation skills as we get older, is that, for me, that starts to make me wonder, why don't we have driving tests as we get older, right? Should everybody who is 90 be driving their car? I think no, right? I think that the literature supports that there is a point in time where you are not able to anticipate or move quickly enough to deal with something dramatic and quick. Right? So I think we should have driving tests from the age of arbitrarily 65. Right? Here's the problem, though, in this country, is in very many areas in this country, you don't have public transport. So, if I am 90 and you take my car away, and I live 50 miles from the nearest town, what happens to my social life?
You don't have one.
Right? Don't have one. And the social literature would say one of the things that it's really important to do as you get older is to stay socialized, to have friends, to go out and do things, to leave the house. Because otherwise what we see is your world shrinks and shrinks and shrinks and shrinks, and your world becomes one room in your house, and then why bother getting up in the morning? Right? So, from a motor development perspective, we have definite indication that we should, not everybody should be driving cars and flying planes. Okay. But from a social, psychological perspective, what do we do if we take that away from someone? So it's quite a complicated picture when you look at the whole thing and not just at the developmental angle. The piloting idea is really fun. There's a lot of motor behavior research done by the military, because if they build the plane or the helicopter wrong, they crash, because from a motor development anticipation perspective, I can't react to that quickly enough. And so lots of things you'll see in the car industry, they spend a lot of time. Where should the indicator be, right? On a panel in a plane. If the light is blinking here, the button I have to touch or do in response to that light should be there. If the light blinks here and the button is over here, we see a delay in response. So there's a lot of research on this idea outside the field of sport and movement and our usual idea of movement, because when I'm designing cars and I'm designing planes and fancy helicopters, then this stuff plays a role, right? A Black Hawk helicopter is very, very, very expensive. The shape of the seat is wrong, the helicopter crashes, right? So not only did I throw away millions of dollars in that piece of equipment, it's unlikely anybody walked out of that crash. So whoever was on the helicopter didn't make it either, right? So that makes it even more expensive, because nothing's worth someone's life. Compensatory strategies then, right? So if you want to teach older adults, if you want to go work at a rec center or a senior center, or you have grandparents or your own parents as you get older, then one of the things that helps a lot is their knowledge base in the thing that you're teaching them. So the more you explain to them about what they're trying to learn, the more understanding they have, the better they become at being able to anticipate and guess where they're supposed to go. And so that can offset some of the slowing for them. Right? If you're working with the children on the playground, we don't bother trying at 3 and 4, probably not until they're 7 and 8. At 3 and 4, I'm not going to try and explain to you why I want you to do this. Just do it. Right? I'm not going to explain the biomechanics of a long step to throw the ball hard to a 3-year-old. Okay? I would explain the biomechanics of a long step to a 60-year-old, because it would help them out. Okay. 11:30. Take 5 minutes, go out in the sun, walk around, get some fresh air, come back, and we'll do some review. Okay?